Thanks for having me in this interview. Yeah, so my name is Michael Metzger. I'm an assistant professor in Canada at Dalhousie University. And over there, we have a research partnership with Tesla, where we develop all kinds of battery technologies. We focus very heavily on lithium-ion batteries, but also recently we have a big sort of effort in sodium-ion batteries and became quite interested in that technology. Of course, we're sort of aware that the battery industry will have to scale up very rapidly and very massively over the next couple decades, right? If we want to meet our environmental goals. And, we're developing lithium-ion technologies that are based on abundant elements and also fairly low in cost. But I think we need sodium-ion batteries also as an alternative. I think it's very important that we get this technology ready so that we can use it when, the lithium availability or maybe the ramp up of the lithium refining capacity cannot meet the demand of the industry. So, here at the Sodium-Ion Battery Conference, I think we have heard very interesting talks on various kinds of cathode materials. And I mean, my personal opinion is it's great that we have all those researchers working on different types of active materials, and everything that works, we need it. But we made a choice that we focus on the layered oxide positive electrode materials. That is based on some initial calculations we did when we entered the field. We believe that energy densities will be highest if we use the layered oxide materials. And also, I believe that, these materials can achieve a very good lifetime. There are also issues, like the environmental stability of these materials. We're working towards overcoming those. So I think it's a fairly promising technology for the positive electrode. Yeah, so in my presentation yesterday, I showed that we can very effectively stabilize these layered oxide materials against moisture and CO2. And, that's sort of building on what other colleagues in the field have done. And basically what we introduced is the use of calcium, small percentage of calcium, 2 atom percent, which can greatly stabilize the material against moisture and CO2. So that's very important, if you want to process materials like this in a factory. And then the other aspect of my presentation was on the lifetime that we can achieve, from sodium-ion batteries with these kind of materials. And, I mentioned we do a lot of work also on lithium-ion batteries, right? So we compared the lifetime of sodium-ion batteries with these layered oxides to LFP-based lithium-ion batteries, and we showed that at higher temperatures, these materials perform very well. And sodium-ion batteries can last for many 1,000 cycles, and achieve really great lifetimes with very good capacity retention. That's pretty exciting for us. Yeah, we have to be really realistic about this technology. And, of course, the lifetimes that I just described, it is achieved by also limiting the upper voltage that these batteries are charging to. So in the future, I think a big challenge will be to enable good lifetimes at higher voltages so that you can achieve greater energy densities. So ultimately, I think for us, the biggest challenge is we want to make these sodium-ion batteries achieve the same volumetric energy density, so watt hours per liter, as LFP-based lithium-ion batteries. I don't think they will be ever, as energy dense as the best lithium-ion cells, but at least our target is to be as good as the LFP-based.
Yesterday I see the life cycle is maybe will increase very quickly and get better in the future, maybe in next year or?
Exactly.
Yeah.
We have to go step by step,
Yes, yes.
one thing at a time. So yeah, I think, it's great to see all the colleagues in the field working hard on this technology. And of course, here in China, so it's very impressive what's happening in sodium-ion batteries. Yeah, so I mean, in a big picture situation, I envision that we may want to use high-performance lithium-ion batteries for electric vehicles, medium, long-range electric vehicles.
Yes.
But maybe we can have small electric vehicles, or two-wheelers based on sodium-ion. And also, we will need a lot of storage capacity for storing renewable energy, like wind, solar energy.
Yes.
So, but maybe we should do that with sustainable, low-cost sodium-ion batteries, so that the lithium resources can be used for other applications, but they are best used. So, and yeah, you mentioned high temperature lifetime, also low temperature performance. I think if we can enable these things from sodium-ion batteries, maybe the energy density is not that critical, and we can have nice energy storage systems for stationary applications that are based on sodium-ion.
Yes. So that is what to do now. We provide the application for the two-wheelers, for the home ESS system, for the data center, and for the CM9 big ESS system.
Well, I can tell you that our students in Canada, they are very excited to work on sodium-ion batteries because it's a very rapidly growing field. It's sort of a little younger, where there are still many challenges to solve. So I think, my advice to new students is, explore something out of the box, right? Which is a little unusual maybe, and I think there are great things to work on in sodium-ion, like personally, I am always convinced that we first need to really understand the problems, like the aging of these batteries if we want to solve it. So I think it's a really nice problem for new students to come in and try to understand what limits the lifetime of the sodium-ion batteries and how can we overcome it. And I think that's definitely something that I think a new student can take on and then solve in the future.
Okay, so the future of the sodium batteries, we are look forward to. So we are make sure we will have the big and very good future of the sodium battery.
Exactly. Yes.
So today
we all need to work hard to make it happen.
Okay. So
Okay. Well, thanks very much.
Thank you very much.
Okay.